Okay, so guys, let us move on to our seventh contestant. He is the furthest contestant so far in this heat because he came all the way from Limbang, Sarawak. That's very far. I just hope you didn't swim or walk here, like literally. Okay, so he is a physics gentlemen, teacher. Please welcome Mr. Yii Tiew Lee.
Testing. Okay, good morning everyone. Suppose that both an elephant and a leaf fall from a high tree, which encounters the greatest force of air resistance in falling to the ground. The elephant, the leaf, or both the same? The answer is the elephant. Okay, note that although the effects of air resistance against the leaf are more pronounced, okay, but actually, the actual force of air resistance against the elephant is much greater compared to the leaf. This is because the larger elephant travels much more air, okay, compared to the smaller leaf. And also, the heavier elephant falls faster compared to the leaf, increasing air resistance even more. A leaf is very light, perhaps fraction of an ounce, so doesn't fall very fast in the air. That as resistance it encounters build out to the same fraction of an ounce. When this happens, the leaf reaches its terminal velocity. What it means by terminal velocity? It means that acceleration terminates and the leaf will move with constant acceleration and resistance also remain unchanged throughout the remainder of the fall. Okay, and an elephant fall from a high tree, on the other hand, will fall very fast, okay, from a very same height. So it will build out the air resistance that same amount to about 20 pounds, which is much greater compared to the leaf. It's only fraction of an ounce. Okay, when this happens, okay, that's why the air resistance that encounters by the elephant is really greater than the leaf. Now, let us look at the second situation. What if now we put a leaf on top of an elephant and both of them are fall from the high tree again? Okay, now I'm asking, which will reach the ground first? Okay, our intuition would tell us that the leaf must stay behind the elephant in falling to the ground. But, want to try and see, have a look? As you all can see, when a leaf is put on top of an elephant, both will fall at the same rate. It is because there's no air under the leaf. So, no air resistance. Then the leaf can fall just as fast as the elephant. Thank you.
Questions and feedback from the judges?
Yes.
Explanation of terminal velocity. One thing I want to ask you, what happens if you do it in vacuum?
In vacuum is considered as a free fall. In free fall, all the objects were pulled down by only the effects of gravity. So it means that all will have the same acceleration. But in the case I'm explaining is we have an elephant and a leaf. And then still remember the Newton's second law of motion, F equal to ma. Acceleration is due to forces divided by mass of the object. That's why a bigger elephant has a greater mass compared to the force against, F equal to ma, so it means A equal to F divided by m. So although force has a larger mass, but the force acting on the elephant also relatively bigger. Compared to the leaf, it has a smaller mass, and then the smaller mass, that's why both will still fall down at the same acceleration.
But are you sure because you put the argument just now, the leaf slow down because of the air resistance. Now I remove my air, I put in vacuum, there's no more air resistance. Won't the leaf and the elephant fall at the same time?
Yes. As I explained to you just now, when I put the leaf on top of an elephant, there's no more air. Yeah. Okay, in the vacuum, according to free fall, both will reach the ground at the same time.
Can I ask what the practical application of this knowledge is? What is it useful for?
Practically, because normally what we taught in the school, we just mentioned about the free fall. Okay, all will fall down to the ground at the same time practically. I'm sorry, for the time being, I can't give any example as I remember.
All right, Mr. Yii Tiew Lee, thank you very
Okay.
much for the presentation.